Hello everyone. For today's online class, I would like to tell you about MGWR and GTWR. Before we start, I would like to overview about the spatial analysis and traditional statistics. In order to make a model for our datasets, we often want to find the relationship between the dependent variable and independent variables. In global models, the relationship between variables are really consistent across the study data. So a single global model often masks a critical local variations. And since the global model only gives a single value of coefficients and assume this coefficient could works for all study area, and then we call this process as the stationary process because they assume all datasets could be predicted within one single value of coefficients. But since in reality, for example, we can take example of house price in here. Some house price in urban area often higher because it, for example, it located nearby train station, it located nearby the university. The house price in here often higher due to some of variables. But in rural area, the house price often have a lower price, even though they have a similar house area in urban area. But in reality, the house price in rural area often having a much lower price. So this phenomena we call a spatial heterogeneity, which means that the impact one variable on another can change significantly from one location to others. So assuming a single or uniform relationship, or we can call spatial stationarity in global models, can lead to massively specified model and a biased conclusions. So first, in order to make a baseline models, we often do the OLS as a global models. As I mentioned before, OLS only creates a single regressions for an equations to explain the relationship across the entire datasets. So it assumes the data generating process is stationary over the place. So on all else means that one model could fit all datasets, and a single value of coefficient in here is calculated for each explanatory variables representing the average relationship of with the dependent variable for all area. For example, in here is the house price, and the x1 is the house area, and b and the x2, for example, is the house age. So since they only have one relationship value or one coefficient value, this value represent how the relationship between house area and house price for whole area or all datasets. The core assumption of the OLS is the data have the spatial stationarity, and as I mentioned before, the model assumes the relationships are consistent everywhere. The limitation of these models or global model of OLS, it can miss or misinterpret the important local patterns and variations. So as I mentioned in previous slide, OLS cannot identify where For example, the house area become more important, for example, in urban area or in rural area. In urban area, we think the house area is more important compared to rural area. So this matter cannot be interpreted by the OLS. So to address that matters, previous study developed the GWR models. I think Professor Ko already explained it last week, where GWR models consider and relax the stationary assumptions by fitting unique regression model for every feature or every sample that incorporate its spatial neighborhood. How it means? It means that in GWR, we will calculate and do the regression for each datasets. So for example, like here, if we want to, in GWR, we will do regression for each dataset. For example, this is the first datasets. And to calculate the regression for these datasets, they will account or include the neighboring datasets nearby. For example, in here, if we want to do the regression in here, we will include the samples nearby. We can take the samples either by distance or either by the number of points. It can be called as neighborhood concept, where each local model is calibrated using a neighborhoods or nearby data points, with closer points having more influence. And for lingering assumptions, while coefficient vary locally, GWR assumes that all relationships operate at some spatial scale. Well, all exponential variables must use the same neighborhood size. In GWR, since they calculate local regressions, they will take the datasets or include datasets in nearby using distance or number of points. So they will set a specific distance, for example, like 100 meters from this dataset to the nearby. And this is, for example, the buffer. So they will include all dataset within buffer into the regressions, and they will have a specific coefficients. And they do the same thing for the other sample or the other features. They will take the same bandwidth value or distance, for example, in here the same 100 meters, and they will calculate the regressions in this within 100 meter buffer area, and they will get a specific coefficient value, and they do the same thing in all area. But you must be note, GWR use the same buffer area size for its features. But in reality, some variables, for example, like house age and house area, maybe have different impact size, or we can say different bandwidth. So to solve that problem, a recent study introduced MGWR. And MGWR, in here, they allow the spatial scale or neighborhood bandwidth to be unique for each explanatory variable. So MGWR recognizes that different spatial scale can operate in different variables. For example, the influence of elevations might be more geographically widespread than influence of proximity to park. And you can see in this figure also, if we want to predict crime based on income and populations, maybe income have a smaller scale or smaller more local impact to the crime compared to the populations. So in here, since they have different impact area, we cannot assume the impact of income and population are the same. So that's why we want to use MGWR, since the bandwidth or the size when you calculate the coefficient for income and coefficient value of population, all this all different. So by optimizing a spread bandwidth for each variables, MGWR can more accurately model this complexity with multi-scale relationship. And usually it leads to more accurate coefficients estimate compared to GWR. So this is the difference between OLS, GWR, and MGWR. For OLS, they keep the model as global, so they only have one set of one value of coefficient for entire study area. And the assumption in here, the coefficient is stationary. But for GWR and MGWR, both of them are local, but in MGWR, they use different scale of bandwidth for each variables. And the coefficients are the same, vary by locations. And the spatial scale, as I mentioned, for GWR, they only have one scale for every variables, or we can say a single bandwidth for every variables. But for MGWR, they have different scale for each variable. The strength of each model for OS, they are simple and easy to interpret. For GWR, it can capture the spatial heterogeneity, and for MGWR, besides it capture the spatial heterogeneity, they can also capture how the impact of the each variable for the dependent variable. There are some limitations of OLS in here. Since they are stationary, they ignore the spatial heterogeneity. And for GWR, since they only have single bandwidth, they assume all the variables have the same impact scale. But for MGWR, the limitation is they have a very long computational time. In order to make sure if MGWR is the right method to use in your analysis, first, you need to consider whether you need a local or global models. If you sure your relationship is vary across the area, for example, like I mentioned before, house price, where house price being high in urban area and being low in the rural area, and the relationship between house price and, for example, like house area in different region are different, you need to use a local model. And the second, do you need your independent variable or explanatory variable operate at different spatial scales? If yes, you need to use the MGWR. And the third, you need to make sure how large is your data sets. If your data sets have like hundreds until thousands, for example, like 1 until 2,000, I think you can use MGWR. But if you have like more than 10,000 or until hundred of thousands, you need to remember MGWR needs very extensive computational time. So you just need to make sure about this. There are several applications for the MGWR, like urban planning and real estate, like predicting house price, environmental science, like predicting PM 2.2 based on like land use data sets. In traffic safety, you can predict crash or crime based on like populations, income, and others. There are several consideration when you selecting the how we select the specific bandwidth method. In here, there's 4 considerations for selecting the best and optimal bandwidth. Since for GWR and MGWR, we need to define how far the bandwidth and how large the bandwidth that we use for calculating the local regressions. This value will be very sensitive. Whether the local regression is very small or the local regression needs a larger area. So the bandwidth value in here is pretty sensitive and will influence your model performance. The first method is golden search bandwidth. When in golden search bandwidth, it uses iterations and search a combinations of bandwidth value, and it will try to find the lowest AIC based on this combination of the bandwidth value. So the benefit of this is, of course, they will maximize the model accuracy, but the disadvantage in here, it takes the longest time, especially if you have the larger data sets. The second is gradient search. It uses the gradient-based optimization to find the lowest AIC. It can benefit for larger data sets, and for the other benefit, it also less time consuming compared to golden search. But the AIC still not better than golden search. The third is manual interval. In here, you can set a specific range for the bandwidth increment. For example, if you have a study area of 1 kilometer, for example, in here is 1 kilometer, you can set a specific bandwidth. For example, you only want to calculate the local area for like 100 meters. So you can set a range between 10 to 100 meters for the 100 meter for the bandwidth size. So by specifying the range with the smaller range, you can get a faster and alternative to golden search. Can be used when you have a good idea, like how big the potential range of bandwidth. And the last is user defined. User defined is you can specifically set the number of bandwidth. For example, like you understand how the impact of the variable, for example, like house area will only impact like 100 meters to only 100 meters. So you can set the number of bandwidth like 100 meters directly. And usually for the previous study and current study, they use either golden search or gradient search. For this both method, they are quite comparable in terms of AIC, but in terms of the runtime, the gradient sets are much faster and have low memory usage, but the accuracy difference are not significant. So if you have larger data sets, you can use the gradient search. But if you have only like hundreds until 1,000 or 2,000, you can use the golden search to find the best optimal bandwidth. And next, we will start to learn how interpret the model outputs. The first thing that we need to do after we got the result of MGWR or GWR model is to find the model diagnostics, and we need to assess or evaluate the model performance first, and we can see like the R square and AIC. Both R square and AIC are representing the model fitting. For R square, the higher value indicates a better fitting, but for AIC, lower value indicates a better fitting. Yeah, it's quite different. But in here, most research often use AIC since they also consider about the model complexity. So they consider the model penalty when they use more variables. And this is also the same, the degree of freedom. It considers the model complexity, where the higher value indicates a simpler models, which means the model have less variables that need to be considered. And it also used to avoid overfitting. And we also need to evaluate the residual variance, where a smaller residual variance are also better. And we also need to learn how we visualize the coefficients. In here, the output of coefficients layer can be interpreted as follows. And in here, when you generate GWR in RGs or QGs, or you run MGWR in RGs and QGs, in the end, they will generate a map like this. So the map in here represent how strong and how the directions of its relationship between dependent variable and independent variable in its area. For example, in this area have a blue color. In the blue color, they show like a value of 0.5, for example, or 0.6, something like that. It means that in this area, if we take house price as example, in this area, the house price and house area have a strong positive association, which means that higher house area will increase the house price. So if this area have the blue color, it means they have positive, strong association or strong relationship. But in contrast, for the red area, for example, in here, they have value of negative 0.2, for example. It indicates in this specific area, they have a strong negative association between house price and house age, which means higher house area I mentioned before. It means if the house area is larger, it means the house price is lower. So that's how you interpret the coefficients. And specifically for MGWR, since they have different bandwidth value for each variable, so we can further interpret the models. For example, if the data is, the variable of for here, for example, is temperature, have a bandwidth feature of 75%, which means it almost reaches 100% of your data sets. Larger bandwidth indicates a more global process, which means they include almost all data, similar like OLS. So the variable relationship with the dependent variables are very similar to OLS and change slowly, consistently across study area. So if your variable have a lot of bandwidth value or bandwidth features, like more almost reaching 100, for example, most of them are 80, 90, and 100. I think you can use OLS, and since OLS have a more simpler model, maybe OLS model is enough to model your datasets. But if your variable have a lot of small bandwidth like this, it means it indicates a more local process, and the relationship of this variable change quickly over short distance. So if your bandwidth are pretty large, usually the figure will have the same color for all area. But if your bandwidth are small, like this, they will show like varying color. They will have the different type of color. Maybe in here here is red, in here is blue, there's a yellow. So they have different color in one map. And then the last thing that we need to consider is how we prevent the multicolority. In GWR and MGWR, multicolority is one concern. And to avoid this cause, first we need to make sure whether the variable that we include doesn't have a clustering problem. And second, we need to, after we do the OLS model, we need to check the variance inflation factor of VIF and remove the variable with VIF more than 5. And also we need to avoid a small neighborhood, like we need to include at least hundreds of data or thousands of data sets. So we can make sure the local samples or local data sets that we include in the models, for example, like here, if our data is too few, something like this, so we only can include like 5 or even 3 data sets into local regression. So this is not optimal. So you need to make sure you have enough sample so you can include more sample in your local regressions. So that's the things that you need to consider. So next we will continue to GWR.